So an equation of the form ax plus by plus c is equal to 0 provided a and b are non-zero constant. So that means they cannot be equal to 0. We know the slope-intercept form of equation of line is y is equal to mx plus c. Here a, b, c represents the constants in the standard equation or the general equation of a straight line, and x1 and y1 represents the coordinates of point P. Hello everyone, a warm welcome to one and all. This is Yashruti ma'am lecturing in Vidyashram, the Temple of Excellence, Mysuru. In today's session, we are going to discuss about the general equation of a straight line. So in our previous session, we have learned how to form an equation of a line in the form of a general equation using point slope, slope intercept, intercept form. So here we are learning the general equation of a straight line. So an equation of the form ax plus by plus c is equal to 0 provided a and b are non-zero constant. So that means they cannot be equal to 0. Then this equation forms a straight line. So this is the equation which represents a straight line which is in degree 1. So an equation or any linear equation of the form ax plus by plus c is equal to 0 provided a and b are non-zero always represents a straight line. Now we have learned many forms of the equations of a straight line, that is using point slope form, 2-point form, intercept form, slope intercept form. So all these forms can also be expressed or derived from the general equation of a straight line. Now we will learn how to reduce the general equation to other forms. The very first one is the slope-intercept form. We know the slope-intercept form of equation of line is y is equal to mx plus c. So here we need m, we need c. Now using the general equation of the line ax plus by plus c is equal to 0, then we can also convert this in the form of y is equal to mx plus c. So here the slope m is given by m is equal to minus a by b. Here a, b, c have numerical constants and y-intercept c is minus c by b, and thus when you substitute here, then the slope intercept form can be reduced in the form of y is equal to minus a by bx plus minus c by c. Now let us see here ax plus by plus c is equal to 0 can be written as by is equal to minus ax minus c. If we divide this by b, then y is equal to minus a by b x plus minus c by b. See, this is how we can reduce the general form into slope-intercept form, where slope is equal to minus a by b and y-intercept c is equal to minus c by b. Next one is the intercept form. We can also reduce the straight line ax plus by plus c in the form of x divided by a plus y divided by b is equal to 1, where a is an x-intercept and b is a y-intercept. So after reducing, the x-intercept take the value minus c by a and y-intercepts take the value minus c by b, where a, b, c are the constants in the equation of a straight line, and hence we have an equation x divided by minus c by a plus x divided by minus c by b is equal to 1. Find k if the lines 2x minus 3y plus 4 is equal to 0 and x plus ky is equal to 3 are parallel and perpendicular. So we know that when two lines are parallel, their slopes are equal, and we also know that when two lines are perpendicular, the product of their slope is equal to minus 1. So let us use the condition. Now let us find the slope of these two lines. We know from the general equation of a line, the slope m can be written in the form of minus a by b. Now here let me convert this as m1. So minus a by b means it is minus 2 divided by minus 3, which is equal to 2 by 3. Now m2 slope. So here this can be written as x plus ky minus 3 is equal to 0. So we can change it into general equation. Now here a value is 1 minus a divided by b. So we have minus 1 by k as the slope. Now for the first condition, since the lines are parallel, we have m1 is equal to m2. So therefore here 2 by 3 is equal to minus 1 by k. So which is equal to k is equal to minus 3 by 2. And for the second one, we have perpendicular. So when I say it is perpendicular, m1 into m2 is equal to minus 1. So m1 is 2 by 3 and m2 is minus 1 by k. So 2 by 3 into minus 1 by k is equal to 1. So k is equal to, here it is minus. So we will get here 2 by 3 minus 1. We can cancel minus. So k value is 3 by 2 if in case they are perpendicular to each other. Next one, find the equation of the line which has y-intercept as 3 by 2 units and it is perpendicular to the line 2x plus y is equal to 1. So to form any line, we need two conditions and here are the two conditions given. Y-intercept, so that means they have given c is equal to 3 by 2. So when y-intercept is given, we can think about a slope-intercept form. If we find the slope of a line, then we can write the equation of a line. So here they have given the line is perpendicular to 2x plus y is equal to 1. Now since the lines are perpendicular, so let me consider the slope of the required line as m1 and slope of this line is m2. So therefore, m1 into m2 is equal to minus 1. We don't know what is m1. So if we find the slope of this line, this is minus a by b, which is minus 2 by 1, which is equal to minus 1. So m1 is equal to 1 by 2. So this is the required slope. Hence, by slope-intercept form, we know that y is equal to mx plus c. So y is equal to 1 by 2x plus, they have given y-intercept here 3 by 2. So 3 by 2. So which we will get as 2y is equal to x plus 3, or we can rewrite it as x minus 2y plus 3 is equal to 0. So this is the required equation of the line. Next one, reduce the equation 3x minus 2y plus 1 equals 0 to the slope-intercept form and intercept form. Slope-intercept form needs slope and intercept, that to y-intercept. Intercept form needs x-intercept and y-intercept. So to find the slope, m is always given by minus a by b. So which is minus 3 by minus 2, which becomes 3 by 2. Now y-intercept c is equal to minus c by b. So which is minus 1 divided by minus 2, which is equal to 1 by 2. So therefore, in slope-intercept form, equation becomes y is equal to mx plus c, which is 3 by 2x plus 1 by 2. Y or 2y is equal to 3x plus 1 or 3x minus 2y plus 1 is equal to 0. So the same equation in slope-intercept form is y is equal to 3 by 2x plus 1 by 2. So if we reduce, we will get back the same equation, and hence in slope-intercept form, the equation of the line is 3 by 2x plus 1 by 2. Now let us try to rewrite this in the intercept form, that is x by a plus y by b is equal to 1. Now we need the value of a, which is x-intercept, that is given by minus c by a. So minus 1 by 3, and we need b, which is minus c by b. So minus 1 divided by minus 2, which is equal to 1 by 2. So therefore the intercept form is x by a plus y by b is equal to 1. So x is divided by a is minus 1 by 3 plus y by b is 1 by 2 is equal to 1. So if we solve this, we will get back the same equation, 3x minus 2y plus 1 is equal to 0. And this is the intercept form of the general equation. Next question, find the equation of the line passing through 2, 2 and parallel to 2x minus 3y plus 1 is equal to 0. So given the line is parallel to 2x minus 3y plus 1 is equal to 0, and hence their slopes are equal. So therefore, since lines are parallel, we have slopes are equal. So therefore, we can write m as the slope of this line only, that is minus 2 by minus 3, which is equal to 2 by 3. And since it is passing through 2 comma 2, so using point slope form, we can write the general equation, or we can write the equation of the form as y minus y1 is equal to m into x minus x1, where x1, y1 is the point. So therefore, this becomes y minus 2 is equal to 2 by 3 into x minus 2. So solving this, we have 3y minus 3 2s are 6 is equal to 2x minus 2 2s are 4. So we will get 2x minus 3y. So minus 4 plus 6 becomes plus 2 is equal to 0. So this is the required equation of a straight line. Next question. Find the equation of the line perpendicular to 3x minus 2y plus 1 is equal to 0 and passing through 1 comma minus 2. It's the same condition. So we have two lines are perpendicular. So therefore, the product of their slopes will be equal to minus 1. So let me keep m1 as it is. m2 is minus a by b. b is minus 2, which is equal to minus 1. So m1 3 by 2 is equal to minus 1. So m1 is equal to minus 2 by 3. Now this is the slope and this is the point where the point is passing. So therefore, the required equation can be written as y minus y1, which is minus 2, is equal to m1 is minus 2 by 3 into x minus x1, which is 1. So solving this, we will get 3y plus 3 2s are 6 is equal to minus 2x minus into minus plus 2. So we will get the equation as 2x plus 3y plus 4 is equal to 0. So this is the required equation of the straight line. Next, we come across the concept called length of the perpendicular. So what do you mean by the length of the perpendicular? So assume that we have a straight line and we have a point. So what is the distance between the point as well as the straight line? So it is always the shortest distance, and that shortest distance is the perpendicular. So we need to find the length of this perpendicular, which is written as d. And it is if the point P is of x1 comma y1 and ax plus by plus c is equal to 0 represents the straight line, then the distance of a point from the line or the length of the perpendicular is given by d is equal to ax1 plus by1 plus c divided by square root of a square plus b square. Here a, b, c represents the constants in the standard equation or the general equation of a straight line, and x1 and y1 represents the coordinates of point P. Next one. So the same length of the perpendicular from the origin. So if the point is origin and if it is a straight line, so let us consider this as x and y coordinate. So this is a straight line and this is point P. So what is 0, 0 or x1, y1? So here x1, y1 becomes 0. So this is 0 plus c, and hence the formula reduces to c divided by root of a square plus b square. So this is the length of the perpendicular. So the length of the perpendicular means it is the shortest distance between a point and the line. So thus here the length of the perpendicular from the origin is always c by root of a square plus b square, and here I have used the symbol modulus because the distance is always positive. Next one, distance between the parallel lines. So we know that the distance between the parallel line is always again the perpendicular distance, And the distance between two parallel lines is the length of the perpendicular from any point on the line to the other line. So that is the shortest distance, and hence here also length of the perpendicular is given by the formula D is equal to C2 minus C1 divided by root of A square plus B square. For any parallel lines, we know their slopes are equal. So slopes are equal means M should be equal to minus A by B. So in both the case, AB value will be the same. To calculate slope, we'll use the formula minus A by B, and since the two lines are parallel, their slopes must be same. Their slopes must be same, the values of A and B must be same. So therefore, here you can observe two lines who have AX plus BY same, but they only difference with the constant C1 and C2, and hence here the distance is given by C2 minus C1 divided by root of A square plus B square. Now let us take all these concepts with respect to the problems. Find K so that the distance from 2, 3 to the line 8x plus 15y plus K is equal to 0 may be equal to 4 units. We know the formula, distance is equal to ax1 plus by1 plus c divided by root of a square plus b square. So here, this is A, this is B, this is C, and this is our x1, this is our y1. So let us substitute all the values inside the formula. Also they have given the distance is equal to 4 units. So D is 4. Now AX1 is 8 into 2 plus BY1 15 into 3 plus C is K whole divided by root of 8 square plus 15 square. Now 4 is equal to 16 plus 45 plus K divided by square root of 289. So then this is 45 plus 16, which become 61 plus K divided by 17. Now 17 fours are 68 is equal to 61 plus K. So therefore K is equal to 7. Hence the constant K is equal to 7. Find the distance between the parallel lines. 3x plus 4y minus 7 is equal to 0 and 3x plus 4y plus 13 is equal to 0. So we know the distance between the parallel line is given by C2 minus C1 divided by root of a square plus b square. So we can write this under the modulus. So the value of C2 is 13 and the value of C1 is minus 7. And AB is 3 and 4. So 3 square plus 4 square. So here we will get 13 plus 7, which is equal to 20. Square root of 25, which becomes 5. So 5 ones are 5 fours are. So therefore distance is equal to 4 units. Show that the point 1, 2 is equidistant from the lines 4x minus 3y plus 7 is equal to 0 and 5x plus 12y is equal to 16. So let us find the distance of the perpendicular of both the lines from the point 1, 2 and show that they are equal. So we know that D is equal to AX1 plus BY1 plus C divided by root of A square plus B square. Now let me consider the distance D1 for the line 4x minus 3y plus 7 is equal to 0. Then this becomes 4 into 1 because x1 is 1, x2 is x2 because x1 is 1 and y1 is 2. Next we have plus minus 3 into 2 plus c is 7 whole divided by 4 square plus minus 3 whole square. So now if we calculate this 4 minus 6 plus 7 which becomes 5 and here under the square root it becomes root 25 which is 5. So we will get the value as 1 unit. Now let us calculate the distance D2 with respect to the line 5x plus 12y is equal to 16. This can be transformed to 5x plus 12y minus 16 is equal to 0. And if we substitute in the formula, we'll get 5 into 1 plus 12 into 2 minus 16 divided by 5 square plus 12 square. So here we have 5 plus 24 minus 16, which is equal to 13. 25 plus 144 is root 169, and here again it is 13. So 13 will get 1 unit. We can clearly see the distance of a point to the line 4x minus 3y plus 7 is also 1 unit, and the distance of the point 1, 2 with respect to 5x plus 12y is equal to 16 is also 1 unit. So therefore, D1 is equal to D2, which means the point is equidistant from both the lines. Next question, find the coordinates of a point on the x-axis whose distance from 5x plus 12y minus 12 is equal to 0 is 1 unit. So we know the formula, D is equal to ax1 plus by1 plus c whole divided by a square plus b square. D is given 1 unit. We don't know what is x1, y1, but they have clearly said the coordinates of a point on the x-axis. Any point on the x-axis is always of the form x, 0 because its y coordinate is always 0, and hence here x1 becomes x, y1 becomes 0. A, B, C is given here 5, 12, minus 12. So therefore 5 into x plus B is 12, y1 is 0, C is minus 12 whole divided by 5 square plus 12 square. Now here we will get 5x minus 12 divided by 5 square plus 12 square is 169 root 30, so which is 13. So we will get 13 is equal to 5x minus 12, and if we shift minus 12 there, then we will get 5x is equal to 25. So therefore x is equal to 5. Now since x is equal to 5, the required point is, 5, 0. So 5, 0 is a point on the x-axis which is at a distance 1 unit with respect to the line 5x plus 12y minus 12 is equal to 0. So thus in today's session we have learnt about the general equation of a line and the problems related to general equation of a line. Also we have learnt length of perpendicular under various conditions. I'll meet you in the next session. Until then, keep watching, keep learning and keep exploring. Thank you.